why not? Like I always do. That was my bad. I did send out emails to the ones that I remembered coming in. Try and vote them. But to no avail. Whoa. I didn't know they made those. No, I appreciate it though. Thank you. All right. Nerds. Get out some paper. Graph paper. The best paper. Lainey, did you get some chocolate milk? Good. And they say, as a god, I do not hear your cries. But I do. I do hear them, and they are annoying. It's an extreme color of yellow.
I'm sorry.
Are we, like, doing... I don't know. Looks like you're wearing Michigan state colors.
I felt happy.
You felt happy?
Yeah.
I like how you use the past tense.
This is it.
So, we're going to practice reflecting points. Are you quite finished? So draw yourself coordinate plane. Meow. What?
Can I have like a pencil or a pen or marker? Oh my god.
Your mom was right. Has a temper. All right. I'm going to put a point right here at -2. 1, 2, 3, 4, 5. -2, comma 5. You should do that as well. Yes?
Can I borrow a black Sharpie real
A
fast?
black Sharpie.
Yes.
My most prized of all the Sharpies. Yes, you may. All right, so there's your point. Now we're going to make a line that doesn't suck, hopefully. I'm really bad at this. Usually it comes out to fractions. You guys are all going to hate me. So let's draw a line with a certain equation. You know what? Actually, you're not going to blame me on this. Give me a slope.
2.
Well, rest in peace.
What?
Okay. Now give me a y-intercept.
3.
Ooh, daring. Okay, so if we go to graph that, we've got 3 as a y-intercept because Taylor hates us all. Which may or may not be unrelated to the y-intercept she gave us. And then up 2/1, right? Also down to back 1, if you will. Okay, cool. So we're going to reflect it across that line. So this one does turn out nicely. And I can tell because of this. Observe. Between this point and what we're calling our midpoint, right? Because we know that this is going to be halfway to our reflection. I can make a nice L. This one goes out to all of you. Hi. And if I do that L, again, that's actually going to be where our reflection ends up, A prime. Again, the idea being that this distance here is the same on both sides. Now, this red line that I drew, how do I know that it's hitting it at 90 degrees? Do I? Or do I not? Looks like it should be, but is it? Let's check it. What's the equation of this red line? What's the slope here? 2 over 2, which is a slope of 1. Our black line is a slope of 2. Are they perpendicular? Oh no. So the reason we're doing this is because I saw this yesterday. People were doing this, they're like, I don't need to do any of that stuff. It's all fine. I'll just do what I want, right? Look, it's a reflection. And they were wrong. That's not good. Do you see how this is definitely not perpendicular, right? It has a different slope. Slope is 2 over 2. This is a slope of 2 over 1. Are they flips and change the signs of each other? No. Good God, no. So that's bad. So take this and let it be a reminder to you. It's not going to work out that nicely. Okay? We're going to do what Taylor suggested now with the point that I gave you. And we're going to find out actually where it reflects to. So, draw another one. Negative 2, comma 1, 2, 3, 4, 5 is point A. And we're going to draw our line. Our line has a y-intercept at, well, I'll draw it over here. Y equals 2x plus 3. Intercept at 3. Up 2 over 1 is our slope. Yes, I can. Yep. All right, so now we're going to reflect this point. So what we need to do is you need to find a line that is perpendicular to this guy and goes through point A. Well, if we want a line that's perpendicular to this, we're going to have a slope of what? What's our slope going to be if we need a perpendicular line? Negative 1/2 x plus b. Bless you, child. You're welcome. I kept you anonymous because we're live. All right, so now we need to plug in a point here that we know is on this line. We want it to go through this point, so that's the point we're going to plug in. This guy's coordinate is negative 2, comma 5. There you go. So we're going to plug that in over here. 5 for y. Negative 2 for x. Cool. So when we do this, we have two negatives, which makes a positive. What's half of 2? 1, right? Again, of is the word we use for multiplication. If you don't remember that tomorrow or in 2 days' time, another way to think of this is 2 divided by 2, which is 1, times the top, which is still 1, right? Again, 2 negatives make a positive. I subtract 1 and I get 4 for b. So our perpendicular line that goes through point A is going to be y equals negative 1/2 x plus 4. We're going to pause for station identification. How do you feel so far? Not too bad? Yes.
Where did you get the negative 2 5 point from? Did you just make that up?
I just made that up. So the problem will be presented to you like this. It'll be, hey, here's the point, and then here's your line. Flip it. Okay? So this will be given. Jenna?
Never mind.
You sure?
I understand, yeah.
Okay. Again, take some time to think about whether you do or do not understand. Good job, Jenna. Feeling good? Okay. If you're not sure, think about which line you got lost on. Was everybody good with graphing the original equation? What up? Noah. Here's some paper. We'll practice some reflections, okay? You got a pen?
No.
I got you. Also, take a black Sharpie. Nice.
Wait, so the problem won't have y equals 2x plus 3?
It'll have all that you see here.
Okay.
Does that make sense, right? It'll give you the line of reflection, and it'll give you the point that you want to flip. Eventually, we'll flip figures, but really figures are just lots of points all being flipped, right? So if you can flip one point, you can flip them all. Cool. So that's our line that's going to be perpendicular and goes through A. So that's going to be the line where A ends up on. So when we graph this thing, it's a plus 4. So it hits at plus 4. And then it's going to be down 1 over 2. So we know that our line is going to look something like this. And that's where A prime is going to end up on. It's going to end up somewhere on that line. And I bet you can make a pretty good educated guess at where A prime is going to end up. Looks like A prime should end up there-ish, right? So what we did before was sort of valid, right? Assuming this is correct. It looks like we've got a slope here. Whoa, that was a nice sound. Looks like that's where A prime should be. Let's see if it actually is algebraically, and if it is, then we've kind of learned a way we can cheat, right? Which is good. So, we know that this is the midpoint right here. Let me zoom in a little bit so you can see what's going on. This point right here, that red dot is the midpoint between A and A prime. Again, we're making a guess that A prime is here, but we're not quite sure yet. We're going to do the algebra to make sure it is, to prove it. And the way we're going to do this is we're going to use midpoint formula and say that if I know the midpoint, right, then I should be able to go from here to here, and everything's good. Let's find out if that's true. Does anybody think that this will work or not work? Any predictions? First rule, trust no one. Why did this one not work? Different slope, right? That's not a perpendicular line. Why did I draw my line like this? Why did I guess that that was going to be perpendicular? I didn't be like, okay, that looks like 90, I'll draw it. I just kind of drew it and then assumed. Why did I draw it like this? Why didn't I try to, make it look more 90? Because if you look here, the angle right here does not look like it's 90. So it wasn't like I was trying to guess. I mean, it's close, right? It's close. But I wasn't really trying to guess what 90 looked like. Why did I assume that the line had to go like that? And then I put down A prime. Why do you think?
Because of the reflection line. I don't know.
Yeah. I had a nice dot here, and it was so tempting just to connect them, right? It'd be nice, wouldn't it? But it didn't work. What about here? I said the midpoint's here. Why is that wrong? Yeah. The two what intersect? The black line's our line of a reflection. Shouldn't the distance between A and the line of reflection be the same on both sides? And it's not, is it? Right? I'm saying the midpoint's there. That's not the midpoint. So that's not A prime. If only our line went through that midpoint. Oh, man, then we have a perfect reflection. It'd be super easy. But Taylor gave us an awful line. So now we must suffer for her insolence. So that's not going to be it. That's frustrating, isn't it? Here's what happens every year when I give this quiz. You guys think, I'm smarter than Mr. Mack. I don't need to do all this algebra. I'll just eyeball it. And like 10% of the time it works. But 90% of the time it doesn't. And then it's a complete disaster. Because when you screw up the algebra, I can give you most of your points. Because, look, you said negative a half times negative 2 is 3. Silly goose, right? Minus a half. But when you don't do any of this because you're like, I'm smarter than you, which you ain't, let's be honest, then I can't give you any points, which is bad. Do we see the danger now? Okay, so I don't have to keep doing this anymore? Well, we'll see. So that's not the midpoint. This is the midpoint, where those two lines intersect. Now, I can't eyeball where that point is because it's not a nice point. So I need to figure out where the two lines intersect. How do I figure out where the two lines intersect? I can't just eyeball it. It's gross. What do I do?
Midpoint formula.
Nope, not yet.
Oh,
Because midpoint formula, we need 2 of the 3 points. Right now, I only know this guy. Our prediction was wrong. And I don't know the midpoint, right? I'm looking for that. But if I knew those two, easy, right? How do I figure out where two lines intersect algebraically? Not visually, not geometrically, but algebraically. Has to do with substitution. Has to do with our line of reflection. Oh, I'm sorry. Our line of reflection and our perpendicular. Anybody remember?
2x plus 3 equals negative half x.
Exactly. Where two lines intersect means that's where they agree. A line is just a collection of points, and those points are all solutions to that equation. Meaning that if I took a point anywhere on this black line, like this one right here, that's point negative 1, 1, right? That means when I plug in negative 1 for x, I should get 1 for y. When I plug in negative 1 here, I get negative 2 plus 3, which is 1. So I do get 1 for y. Any point on this line is a solution to this guy, right? That's what the line represents, all the possible answers. Pairs that work together. Something for x, something for y. Same thing for this red line. Any point on this red line, if I plug it in to the red equation, will be a true statement. All those are possible solutions. So where they intersect is where they both share the same solution. Right? So where do they share the same solution? In other words, where do they equal each other? Where this y is the same as this y, and this x is the same as that x. Well, if we're looking for where the y's are the same, let's assume they are, right? If that y equals this, and they're the same y, and that y equals this, shouldn't these equal each other? Again, if y equals 2x plus 3, and y also equals this, shouldn't these equal each other? So we should be able to set them equal and find out what x has to be to make them equal. So we have 2x plus 3. And we're asking, where does that equal? And I'll do this in a red pen. Negative a half x plus 4. Are you smelling what I'm stepping in? We're trying to find out where they intersect, where they agree, where they equal each other. Again, we're trying to find out where they intersect, where they agree, where they equal each other. That's why this makes sense to do this. Where do they agree? Okay? And that's going to be where they intersect, which is going to be our midpoint for later. So now we do some math. We're going to subtract 3 and move that over and add a half x to this side. So what we end up with is 2x plus a half x equals 3 plus 4. When we move the 3 over, we subtract it, right? So I'm left over with 1. Is everybody cool with that? I'm doing 2 steps at once here. We're doing advanced algebra techniques. I'll put it over here. I'm sorry. Two x plus a half x. 2.5 x's, right? Boo, mixed numbers. That's awful. Yuck. That's not a slope. So let's get an improper fraction. How many halves are in the number 2? 4 halves. So another way to write 2 is 4 over 2, right? That checks out. 4 divided by 2 is still 2. And now we have common denominators, so we can actually add these together. 4 halves plus 1 half is how many halves? 5 halves. Alrighty. Now how do we solve a problem like Maria to get x on its own? Yeah.
Multiply by the reciprocal.
By the reciprocal. If that isn't jiving with you, okay, for those of you that understand multiply by the reciprocal, you should get what I'm going to do next, okay? I'm going to break it down into 2 steps. When you multiply by the reciprocal, you're doing it all at once. I'm going to break it down into 2. That's a divides by 2, and that's a times by 5. If it was 5x, what would you do to get rid of the 5? Divide by 5, right? If it was x divided by 2, what would you do to get rid of the divide by 2? Multiply by 2. Well, that's what it is. You can do it one at a time. So what do you want to get rid of first, the divide by 2 or the times 5? Probably division, right? To make a better world, we should always get rid of the division first. Bring people together, you know. So we're going to get rid of the divide by 2 by multiplying by 2. What we're left with is 5x, because we got rid of the divides by 2, and we multiplied the other side by 2 and got 2. Now we divide by 5, and x is going to be 2/5. Now, for those of you that want to multiply by the reciprocal, what's the reciprocal of 5 halves? 2/5. What's 1 times 2/5? Boom, right? You just did it all in one go. So x is 2/5. They intersect at 2/5 comma something. Again, when you get here, you are not done. What we're doing is we're trying to find out where they intersect, the coordinate where they intersect. Well, that's the x value of the coordinate, okay? Now, how do I go find the y value of the coordinate? And I can plug it in either one, because remember, we're finding where the solution is for both of these things, where they both agree. So both of them, when you plug in 2/5, should get the same answer for y. That's the idea. They're going to share an answer, share a coordinate. So plugging in 2/5, would you rather plug it into the top or the bottom? Which equation?
The top.
Top one, probably, right? So let's do that. Y is 2x plus 3 is the equation. I'm going to plug that in for x, because that's what we found, right? So we get 4/5 plus 3 equals y. And again, we shouldn't be surprised that this is an awful answer, because we know where it intersects is a gross spot, right? It's not going to be a nice answer. That's a gross intersection. It doesn't intersect at a nice, lattice position. So we get 4/5 plus 3. So the question is, how many fifths are in the number 3? 15 fifths. And if you're not sure, write it down. Is 15 fifths, otherwise known as 15 divided by 5, is that 3? Yeah. It's the same thing, just a different way of looking at it, right? I've got 4/5, you've got 15 fifths. How many fifths do we have? 19 fifths. Which means our intersection is here. We are not done yet, but we're going to pause for station identification. Because today's the day it's all supposed to click, right? I told you yesterday is the day where it's like, oh my God, right? And then today it's like, oh, okay, all right, okay. Now, I was hoping to start out with an easier one, but Taylor chose an awful line of reflection, which is why we all hate Taylor. Boo! Boo, you like Drake. Boo! Anybody see that?
Yeah.
Poor Drake. Started from the bottom and now he's here. All right. Moment of silence for Drake. I guess on the one hand, he can't be that greedy. He did get his legs back. No one watched Degrassi? You a real G. All right. So this is where the lines intersect. That's the midpoint. We're looking for A prime, where it reflects to. So what we're going to do next is we're going to use that point and the midpoint, which we just found, to figure out where A prime is. And then we're done. But before we do that, how do we feel about this? Setting them equal. We have the original line of reflection. We have our perpendicular. Then we did math and got this. How do you feel about this? Not great, right? We don't like it, but can we do it? Yes? Okay. Do we see that after we get the x, we got to go get the y? We know how to do that? Wonderful. Wonderful. So glad for you, Luke. All right. So now, that's the midpoint. That's the original point. And we're going to flip it using midpoint formula. What is the midpoint formula? Oh, I swear to God. I swear to God. I swear to God. The midpoint is the average of the x's, average of the y's. Thank you, Bo. Bo, when we average stuff, are we adding or subtracting? We're adding, right? So we're going to average our x's. There are 2 of them, right? And we're going to average our y's. So, of course, we're adding. Now, when we average, we add and then what?
Divide by
Yeah, number of pieces, right? That's my boy. Nice job. Also, you killed it on your last quiz.
I know. It's a shocker.
No, it's not a shocker. You're actually good at this stuff. You just suck at writing. Okay? Again, I'll tell you when you suck. You suck at writing, okay? But you're actually really good at math. You can trust me on that. All right, so this is our midpoint formula, right? We know from earlier that our midpoint was that awful coordinate. What was that awful coordinate we got? It was all over 5s, right? 2/5 and 19/5, I believe, right? Okay. Again, these are both coordinates. That's why they have the parentheses, right? We're adding because we're averaging. Now, we know one of our coordinates, right? One of the endpoints. We know A. We're looking for A prime. A's coordinates are these guys, right? X, Y. So what was A's coordinates that they gave us? -2 for X, +5 for Y. Again, if you want to, I would encourage you, whenever you plug stuff in, wrap it in parentheses. I plugged in for X and Y, so I'm wrapping in parentheses. Now, we don't know X2 or Y2, because X2 and Y2 are going to be what? The coordinates for what? A prime, right? The reflected point. So that's what we're looking for. Again, we have a coordinate equaling a coordinate. Well, if two coordinates equal each other, then they must be the exact same thing, right? Like 2, 3 equals, well, the only thing it equals is 2, 3, right? So the x's must equal each other, the y's must equal each other. Meaning that this right here should equal this. And this should equal this. Christmas. Does that make sense? Right? The x's should equal each other, the y's should equal each other. So this right here, they equal each other. Okay, cool. So write that. 2/5 equals x plus a -2. What's plus a -2? What's a simpler way of writing that? -2 over 2. How do you solve a problem like Maria? How do you solve a problem like Maria? Get x on its own. No. Multiplied by 2. We're trying to get x on its own. If we were trying to like combine them, we'd want common denominators, right? But we want to get everything except the x gone, right? So we're going to get rid of the divide by 2 by multiplying by 2. So we get 4/5, right? If you had 2/5 before, and you double it, now you've got 4/5. Again, think of fractions as like units, right? You had 2 chickens, 2/5, right? Now you have 4 chickens, 4/5. You doubled it, right? Now we're going to add 2, and this is where we're going to need common denominators, right? Because we have 4/5 plus 2 equals x. Again, the question is, how many fifths are in the number 2? 10/5, right? And if you write it out, is 10 over 5 10/5 the same thing as 2? Is 10 divided by 5 same thing as 2? Yeah, right? They're the same thing. We didn't change the problem. That wouldn't be allowed. We just made it look different. And looking at it this way is more beneficial because now we know how many fifths we have. 14 of them, right? So our midpoint, we know the x value. It's 14/5. Or not our midpoint, I shouldn't say that. Our A prime is what we're looking for. It's 14/5. We already know our midpoint. Now let's go get the y. Back to the top. This guy equals this guy. So write that. 19/5 equals y plus 5 over 2. We're going to pause for station identification. How do we feel about the right side, or left side, I should say? Set them equal. Multiply by 2. Add 2. Get common denomies. Get your answer. Yeah. Questions, comments, concerns, other than for my mental well-being? No smiling in math class. No happiness! All right. You did this. You did this. What?
Are they all going to be this confusing?
I don't know, Taylor. Are they all going to be this confusing?
No.
Wrong again. Multiply by 2. 19 times 2. Oh, God, that's hard. No, it's not. What's 20 times 2? 40. But we overshot by 2, right? Because we did 1 each time, right? So it's actually going to be 38 fifths. Now what? How many fifths are in 5? 25 fifths, right? Is 25 divided by 5 5? Yeah, we didn't change the problem. Check your work as you go. 38 minus 25. Well, that's 5 to get to 30. 8 more to get to 38. What's 5 and 8 put together? Well, 5 and 5 and 3. 13. 13 fifths. Congratulations. We have found a prime. There she is.
Know that I pray to God that we never have to do that. Yeah.
You seen that meme? Right? With the guy? Got the lips?
Yeah.
You think? Right? I'll find it for you.
Here we go.
I just don't understand. Didn't we learn a different way that was easier to do this?
Is this recyclable?
Yes.
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 What do you mean?
Like a week ago?
What we did before, Michaela? This is a great question. What we did before was I gave you a point and a line, and you had to find the red line, and that was it. Remember, we just had to find the line that was perpendicular? That was it. So we did the first half of this a week ago. Now we're adding on the midpoint part. So Michaela makes a great point. Last week what we did was this. I gave you a point, and I gave you an equation. You graphed that equation, and then you found the line that was perpendicular to it, and you stopped, right? And that was it. And that was hard, but most of you did well with that. We did actually pretty well in that last quiz. Now what we're doing is all we're adding in is the midpoint part, right? Find the midpoint, set them equal to each other, right? And then do midpoint formula to find out where this guy's going to be. Okay, so we're adding on the second half of it this week. Does that make sense? Okay, cool. Jenna, for you, and then Lainey, I have to answer your question.
Oh, that's not the one we were thinking.
What were you thinking of?
Like the one I was like,
Oh, yeah.
yeah.
Right? Yeah, that's not my reaction. I'm thinking of this guy. There are bigger, like there's actually like the full meme, but like I can't show you those because the ones that pop up on Google image search first are not appropriate.
Well, you can say meme appropriate.
Clean.
Or,
Clean
yeah,
memes.
whatever.
It means I can show my grandfather, right?
Yeah.
What?
It's one of these things.
Yes, we can. We're going to do the review tomorrow for that, though. Okay?
Also, I have a question.
Nope, Lainey first.
I'm gonna be honest with you. You lost me after the draft.
Yeah.
After the what?
After draft.
So after.
I second
Like
that.
when we plotted a time in the midpoint line, you lost me.
Okay, okay. So this completely lost.
Yeah.
Yeah. We should just do like a normal.
Okay.
Like I get the midpoint formula and like why you put it there and stuff like that, but all that,
Yes.
It's like you just crossed it out and did.
We're gonna do another. Yeah.
Like, what's the goal here? Yeah.
No.
Literally, what's the goal? Do I get to do
Well, I get
Yes.
one of these things, but not like.
Let me just do this.
Yeah.
Do I have enough?
Not all of them. No. Most of them will not be.
God.
But if you can do it fractions, you're gonna be fine. So if these weren't fractions and you didn't have to get common denominators, would you be okay?
That'd probably help a lot.
You see what I'm saying? But like, if that's the case, I'm gonna do one more of these. Okay? Make sure you're good with everything other than the common denominators. And then once you're good with that, we'll focus on getting common denominators. Nah. Nah.
That would have been very fun.
I did.
Not for this quiz. It's actually not as hard to do as you might think. I can show you how to plot that and get a good estimate. But right now, nah.
So can we go through like one more slow?
Yes, absolutely. That's why we're here today. Now remember, we have today, which is all devoted to reflections, and then we have tomorrow, which is going to be 75% reflections, let's be honest, right? The translation thing ain't that bad. If you don't get it, if you're struggling with it, right, you're like, have questions about it, I bet we can get that knocked out in 10 minutes, right? Yes. Yes, you may. What color?
Can I have a Sharpie too?
Navy.
Black.
Like my soul.
Can I have another one? I really like that. Not a black one.
Pick any color, I'll
Pick a
take
good
it.
color. I already have yellow. Yes, that's really nice. Thank
And
you.
could I get 2 more?
Mint. Perps. All right.
Can I have your least favorite color?
My least favorite color? I don't have a least. Actually, I don't have a least favorite color, but I never use this one. So here you go. In fact, the yellows are always free if you want the yellows, because they just don't show up well
I
on this.
have yellow. Well, you gave it to
Yes,
me.
you do. Yes, you do. All right. So. Let's put a point here. So that's going to be our A. So that's 5 to the right and 1 up. All right, Taylor. Everyone's hating you today, not me. Remember, it's her fault. Shout out to Taylor's mom. All right.
Wait, what am I picking?
You're picking the line of reflection.
Equation?
Yeah, line of reflection. Give me a slope.
The slope is 1.
Boo!
And the wire.
No. We're not doing 1.
Wait, why can't we do one?
Because 1 you can actually eyeball really easily, and we're going to talk about that tomorrow, and it's going to make you feel better, but I don't want to make you feel that good today yet.
The slope is 4.
Excuse me.
No. And the wire intercept is 2.
Okay.
Can you move that?
So that's our line of reflection. How do we graph this? Well, 2 is the slope, or I'm sorry, the y-intercept. We'll do this in blue. And 4 is the slope, right? So up 4 over 1. 1, 2, 3, 4 over 1. We can also go down 4. 1, 2, 3, 4, and back 1.
How do you go? Oh, no.
How do we feel so far? All right, so I'm gonna get a better answer out of this question. If this was all the test was, would you be great?
Yeah.
Chloe,
The graphing, yeah.
write this right here.
Yes.
Hold on.
Yes.
I would be fantastic, but
Yes.
you see that second point, like not at top, but like at the bottom in that line? That one.
So slope can go 4, 1,
Right.
right? Or it can go down 4, left 1. The reason for that is because 4 over 1 is the same thing as negative 4 over negative 1.
Okay, yeah, I get that. It just,
You don't have to do both.
it didn't seem like it was at 4 over 1 from this view, so.
Oh, sure. Yeah.
But, yeah, okay, thanks.
Yep. Cool. I used to have a transparency, and I always had like a coordinate plane here, and it worked out really well, but I just don't have that anymore. Maybe someday, maybe semester 2. It's more efficient. All right. So we feel great about this. Okay. Again, this came from this. Okay. Now, let's find the line that's perpendicular to it. What will the slope be if it's perpendicular? Negative 1 over 4. We don't know what b is yet. How are we going to figure out what b is? We're going to plug in 5 and 1 into our equation because we want the equation to go through that dot, right? So when we do that, we're here. Here's what I want you to do. I want you to stop writing. Eyes up here. I think it'll be better. This worked better for third, fourth, and sixth hour. Try this. So watch me. We agree? Okay. I'm going to add 5 quarters. How many quarters in 1? 4 quarters, right, in 1. Now we've got 9 quarters because I added 5/4. I added this over. We cool? So B is 9/4. So our line is this. So our line that goes through there is going to have a slope of -1/4, and it's going to hit at 9 quarters. So 9 quarters is our y-intercept. 9 quarters is about, I don't know, right here. So it's going to hit like that. Cool. All right. We need to find out where those two lines intersect. So I'm going to set them equal to each other. Yikes. Get my x's together, get my numbers together. When I subtract 9 quarters, that's going to get me -1/4 over here, just trust me. And I move over the -4, and I'm going to get -17 quarters x. Trust me on the math, okay? That's not what we're focusing on right now. Then I'm going to get x on its own. I'm going to multiply by 4. I get -1 over here. I'm going to divide by -17. I get 1/17. That's my x. Trust me on that. Don't write this down. You're not turning it in. There's no point. Okay? So now we take that and we plug it into one of the original equations. Let's plug it into the top guy. So I get y equals 4 times 1/17 plus 2. That's a 1. That's 4/17 plus 2. When I add those together, that's 34/17. So that's going to be 38/17. Trust me on that. And that's y. So here's what I did. I set them equal. I found the x. I went and found the y. You don't care what the numbers are because it doesn't matter, okay? Now that I have that, that's my midpoint. So now I plug that into midpoint formula. We're adding and dividing by the number of pieces. A was 5, 1. Multiply by 2, 2/17. Subtract 5. How many 17ths in 5? Well, it's going to be 5 times 17, which is 50, 30, 85. 85. So it's going to be -83/17. Woo! Good job, Taylor. Do we get the concept of setting it up a midpoint formula, and then we do math to figure it out? Again, the do math part, you might be like, yeah, right? But, like, do you understand the setup and why we're doing what we're doing? That's important. This one, times it by 2, subtract 1. When we do that, we're going to get 38 plus 17 is the shortcut. So 48, 55 over 17. Not that you care, right? And that's where A prime is. So what do we do? Graph the original line. How do we feel about that? Found the perpendicular line. How do we feel about this? Again, weird numbers because of the fractions, but how do we feel about the idea? Plug in the point, do math. Graph the line, we'll talk about that tomorrow. Find where they intersect by setting them equal. After that, take what you found, put it in midpoint formula. How you feel? Better? I'll take better. Well, thank you. Almost made it in the thing. Ah, Lainey, that was a good throw. I want you to know you're going to be okay. You really are.
Sometimes I think that, but sometimes when I look at this graph, I don't think so.
I'm sorry.
That's okay.
Tomorrow, things will be better. They will. I'll have the review guide for you. We'll go through that. You'll notice that most of the quiz, very doable, and will be nice numbers for reflections. There's going to be one that's not so nice. The reason I have to do that is because if I give you nice numbers, then you can just eyeball it, and you don't actually understand the algebra. I'll see you tomorrow. Hang in there. Doing all right? Yeah? Okay.